Okay, so this is section 2.5, page 17. Objective to connect reasoning in algebra and geometry. Okay, so here's the deal. We've seen these algebraic properties of equality before. We're talking about the basics for proof. And we're going to be doing proof with statements and reasons for algebra type proofs at first, and then we're going to do some stuff that proofs that we did in this section. Well, in this chapter, I should say, for notes for this section. So reasoning in geometry and algebra. Okay, if A equals B, then I can add the same thing to both sides, C, to both sides, and that's addition property. Remember, addition, subtraction, multiplication, division, we've used these before kind of loosely, but it has to happen on the same side of the equal sign. Then it's this is addition. I'm doing the same thing, adding the same thing on both sides. If I subtract the same thing on both sides, it's subtraction property, so I'm subtracting C from both sides. So here, what am I doing? I'm going to take A equals B, and then I'm going to multiply the same thing to both sides, and that is multiplication property. In division property, I'm going to divide the same thing on both sides, and I got division property. Remember, I can't divide by 0. That's why I have that restriction that C cannot be 0. Reflexive property, it's equal to itself or congruent to itself. We use a lot of congruence so far in chapter 4, but I'm reviewing stuff for chapter 2. And so we're looking at it's equal to itself. Symmetric property is that A equals B or B equals A. Okay. Transitive property, if A equals B and B equals C, then A equals C, and that's skipping the middleman. Okay. Substitution property, if A equals B, then B can replace A in any expression. That's no problem. We've done that a lot. Distributive property, A times the quantity B plus C becomes AB plus BC. And I can do it in the difference or sum, and A times B and A times C is AB minus AC. So those are the properties we've seen hundreds of times before, and we're going to be using them. We're going to be using the names when we actually do the property. So this will be our statement, something like this, and then we'll have this as our reason. So now we're taking algebraic sentence in 5x minus 18 equals 3x plus 2. We're going to solve it. Okay, well, my reasoning for writing down 5x minus 18 equal 3x plus 2 is that it was given. Now, what did I do from step 1 to step 2? It looks like I subtracted 3x. So I subtracted 3x on both sides, subtraction property of equality. And to go from step 2 to step 3, it looks like I took my 18 and added it to both sides, so I added 18 to come up with 2x equal 20, so addition property of equality. My last step, I'm dividing by 2. Notice I'm not showing them, I'm just showing the result. So I'm dividing by 2 and x is equal to 10, so division property of equality. Now, I'm going to do that in each one here, and as we get going, I'm going to introduce how I do some stuff on both sides and how I talk about getting rid of distributive property too. So here I've got the given, but notice I've got these parentheses here, and able to get rid of the parentheses, what I did here. And I only did it on one side. I'm multiplying the 3 in, but that's a distributive property move, so I'm using distributive property of equality. Now, I'm still leaving everything on the right the same, so I'm doing something different, and I'm combining like terms. So that's a combine of like terms on the left side to go from step 2 to step 3. From now on, it's just me, adding to both sides, so it's addition property of equality, and then I'm going to divide, and it's division property of equality. So it's just, why did I do what I do when I did it? And I'm justifying my steps. Okay. Now, as we go on, I'm going to see what it looks like as I go through this. Now I'm going to justify each step for this proof. And this is a linear pair, okay? And by the linear pair postulate, I know that this, being that they're a linear pair, that AOC and MOC are supplementary. Well, that's what I wrote down, but that's by linear pair postulate. Now, because I said they are supplementary, that means the measure of AOM and the measure of MOC is 180, but that's by definition of supplementary angles. Notice I'm justifying this statement, that these two angles add to 180 degrees, because I was told that they're supplementary. Okay, so well, now I substitute 2x plus 30 in for AOM and x in for MOC. So I've got that substitution. Remember, this is just one big variable. That's all it is, very descriptive. The measure of angle AOM and the measure of angle MOC. Okay, that just represents my variables. Okay, and I plug in my values, so now I can solve for x and find out what each angle is. Now, I'm going to combine like terms. Now, 3x equals 30, so combine like terms. And now I'm going to subtract 30 from both sides, and that's subtraction property of equality. Well, the next step, I've got to solve for x, so I'm going to divide by 3, and I get division property of equality for my reason as I go. And x is 50, and I can check it by just plopping it in, and 2 times 50 is 100, plus 30 is 130 on the left, and 50, so 130 plus 50 is 180. So we're able to move on to our next thing. Now, we're looking at properties of equality when used with segments and angles. So I've got segments and angles on both equality and congruence. Please make the changes on your notes. There are some discrepancies in notes that have to change. On this second part, you need these bars over the top here. They're not in your notes. Please put them there. Now, this is an example of when I use reflexive property when I work with segments. If for any segment, length of segment AB, the length AB is equal to its own length AB. And when I do it with angles, for any angle A, the measure of angle A is equal to the measure of angle A. Symmetric, remember I flip. Okay, x equals 3, 3 equals x, that's symmetric property. Well, in this case, it's AB equals CD, the length AB equals length CD, and the length CD equals length AB. And for angles, if the measure of angle A equals the measure of angle B, then the measure of angle B equals the measure of angle A. So I can switch those that direction. Transitive, skipping that middleman. AB equals CD, CD equals EF. Notice the CD is the same. AB equals EF, and I've got it made. If the measure of angle A is equal to the measure of angle B, and the measure of angle B equals the measure of angle C, angle B can be dropped, and measure of angle A is equal to the measure of angle C as I finish this out. Well, I'm going to use the same properties in congruence. Now, some people get confused about it, but really, when I'm using properties of equality, I'm working with equal signs. When I'm using properties of congruence, I'm using congruence. So that's pretty much it in a nutshell. So a reflexive property, they're very similar, except these are congruent and these were equality. So reflexive property of congruence. For segments, segment congruence, hey look, I got segment AB is congruent to segment AB. For angles, angle AB is congruent to angle A. Actually not AB, but angle A is congruent to angle A. Symmetric, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. Okay? You notice the flip-flop with symmetric. Same idea over here. The angle A is congruent to angle B, then angle B is congruent to angle A. And transitive, same idea, I'm skipping that middleman, so segment AB, CD is gone, CD is gone, you write it. Hopefully you wrote segment EF. Here, angle A is congruent to angle B, and angle B is congruent to angle C, so angle A must therefore be congruent to angle C. Now, we're going to use these in steps. Okay? What is the name of the property of equality or congruence that justifies going from the first statement to the second? So in order to go from this statement to this statement, what happened? And I want you to come up with a reason. Well, 9's no longer on both sides. I took it away. Oh, I subtracted. So this is subtraction property of equality. That's what you're going to do. Fill in the rest and we'll talk about it. Hopefully you took me seriously on this and you're trying to do it yourself and you're going to correct as we go. But I'll just point out what changed. 3x minus 10 equals 5. Well, I added 10 to both sides, become 3x equals 15. So it's addition property of equality. Here, 4x equals 64, now x equals 16. I divided by 4 on both sides, and it's division property of equality. To go from this step to here, and that's why if this and then something happened to get to this, what happened? I must have multiplied by 5 on both sides, so I got multiplication property of equality. In E, oh look, this looks like that transitive property thing, but it's in congruence, so transitive property of congruence. Okay, I skipped the middleman, and A is congruent to angle C. Here I've got the measure of angle A equals the measure of angle B, and I've got the measure of angle B equals the measure of angle A. Boy, you know, it looks like they flip-flopped this. This is symmetric property of equality. And it's of equality because of the equal sign. Now I've got a measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C. Well, I've got the middle man here, and the measure of angle A must equal the measure of angle C by transitive property of equality. And my last one, if angle A is congruent to angle B, and angle B is congruent to angle A, it's got to be symmetric property of congruence. Those are it. Those are the things, the properties we're using. You got to make sure you're careful as we're going through. And let's go on and look at this next section. Now, a theorem, true statement that follows as a result of other statements. A postulate or axiom are facts that are accepted without proof. Paragraph proof is a proof in paragraph form. Two-column proof has a numbered statements and reasons that show the logical order of the argument. So if I have this given, if we read through the given, we're able to come up with what the value of the measure of angle 4 is without even reading my steps. The steps allow us to split up the thought process and let us come to the conclusion with giving reasons as we go why we know what we know. In measure of angle 1 plus the measure of angle 2 equals 66, that was given pieces of information. And so was the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 99. But I combined those two, where I saw the measure of angle 1 and the measure of angle 2, I placed 66. Well, to go to line 3 with these two, I just substituted, so it's substitution. Property of equality, but it's substitution, and substitution is only a property of equality. You cannot use it in congruence. And now if I subtract both sides, 66, I'll be able to get the measure of angle 3 equals 33 by subtraction property of equality. Now, all of a sudden I've got this thing, and this stuff is from the given line, measure of angle 3 equals measure of angle 1, measure of angle 1 equals measure of angle 4. Well, I wrote that down because it's given. Now, notice I put the given in separate lines and then I combine things. It's your choice. I could have put it all at the beginning, but I'm using it as I put it in this time so you can see it to help with the readability of my explanation here. So now I'm going to use that idea of transitive property. I'm going to skip this middleman and know because of these two statements combined that the measure of angle 3 is equal to the measure of angle 4 because of transitive property of equality. Now, I know the measure of angle 3 is 33. So the measure of angle 4 is equal to the measure of angle 3. So the measure of angle 4 must be 33 by substitution. Okay, and that's just me writing a two-column proof with statements and reasons opposite those statements. Now we have two proofs left as we go, and these are proofs for segments. And I've got segment AB and segment BC, segment CD. They tell me AC is equal to BD. That's what I want to prove. I'm starting out with AB equals the CD, okay? Well, that's cool because that's given. Well, I'm going to look at this and I'm going to think, hey, you know, if I add segment BC to both AB and BC to CD, I'll be able to come up with those. And I'm going to add it because BC is equal to itself, reflexive property. The only reason I use reflexive property like this is I'm going to add it to something. So I'm going to add this, and I get AB plus BC equals BC plus CD. Okay, so it's addition property of equality. Now I'm going to use segment addition postulate. Segment addition postulate allows me to say that segment AB plus segment BC is equal to segment AC. And segment BC plus segment CD is equal to segment BD. That's by segment addition postulate. And I'm using an actual fact, just like a resource. Hey, how can I get about proving that AB plus BC is actually AC and BC plus CD is actually BD? Well, I'm using segment addition postulate. Now, by substitution, I know that these two are equal to each other. And in a like manner, I want to emphasize this, like manner, I can do the same thing with these two angles using angle addition postulate. Well, I've got the measure of angle 1 equals the measure of angle 3. This measure and this measure are the same. And they want me to prove that AEC is the same measure of BED. Well, I'm going to do the same thing I did up there, up top, except I'm going to add this angle to this angle and this angle to this angle. So angle 2 and angle 3 are going to be added together. Angle 1 and angle 2 will be added together. And by angle addition postulate, I'm going to show that angle AEC is comprised of the measure of angle AEB and plus the measure of angle BEC, and the measure of angle BED is made up of angle BEC and measure of angle CED. So you'll see that when I write it out, but I'm going to use, in a very like manner, I'm going to do the same thing I did in 6 and 7, except it's going to be about angles. So now I'm going to say that BEC is congruent to itself because of reflexive property of equality, or in this case, angle 2. BEC is angle 2. Now angle 1 plus angle 2 is equal to the measure of angle 3 plus measure of angle 2. I just added the same thing to both sides, okay, by addition property of equality. So I add the same thing. And now I'm going to go, hey, you know, angle 1 plus angle 2 is equal to the measure of angle AEC. Angle 2 plus measure of angle 3 is equal to the measure of angle BED by angle addition postulate. That's what I did there. Now, I'm going to use substitution. See this here, and that's what I was supposed to prove. So I can do this by substitution, and I'm golden. We've got those two things written, and they're very similar. And again, if you're wondering about how to do things better, how to become better at doing proofs, it's knowing your vocabulary, rereading your postulates and theorems, being very familiar with them, and recognizing how to apply them in situations. Those situations don't change. They're the same each time. We just use them in similar situations, and the numbers of the angle or the letters of the segments or the angle themselves will change as we go. I hope that everything is going well so far with you, and that things are improving. If you got questions, again, come on in and see Mr. Bloom.